Hi, today we will learn about direct variation. Here are our objectives. Illustrate situations that involve direct variation, translate into variation statement a relationship involving direct variation between two quantities given a table of values, a mathematical equation, a graph, and vice versa. And lastly, solve problems involving direct variations. Do you agree? So we have here some statements. Number one, the more time I drive at a constant rate, the more distance I cover. This is a true statement. Next, if you increase a recipe for more people, the more ingredients you need. Again, this is also a true statement. In a computer shop, the more hours you play online games, the more money you pay. Do you agree with that statement? Yes. Next, the more apparels I purchase, the more money it costs. Agree. The less time you study, the lower grades or the lower scores you will get in the exam. I guess you will also agree with that. Next, the less water you drink, the less trips to the bathroom you have to make. Also, agree. Next, the more time you play games, the longer your cell phone battery stays. With the number 7 statement, I guess we will all disagree. Now, go back to statements 1 to 6. These situations involve what we call direct variation. Now, what is direct variation? Direct variation. There is direct variation whenever a situation produces pairs of numbers in which their ratio is constant. The statements y varies directly as x, y is directly proportional to x, and y is proportional to x may be translated mathematically as y is equal to kx, where k is the constant of variation. For two quantities, x and y, an increase in x causes an increase in y as well. Similarly, a decrease in x causes a decrease in y. So in short, there is direct variation when as x increases, y increases. And if x decreases, y decreases. And the ratio between them always stays the same. Here are other situations that describe direct variation. As you borrowed more money, more interest to be paid. As you spent more working hours, more work will be done. As your speed decreases, less distance covered. Other examples are, say for example, in a school, the greater the number of students, the greater number of teachers needed. The lesser the number of students, the lesser number of teachers needed. What else? In a family, the greater the number of family members, the greater the amount of food supply needed. The lesser the number of family members, the lesser the amount of food supply needed. Variation statements can be translated into a mathematical equation. Say for example, the distance varies directly as the time. So in mathematical equation, that is d is equal to kt, or k is equal to d over t, where k is the constant of variation. Another example, the cost of electricity varies directly as the number of kilowatt-hour consumption. So in a mathematical equation, that is C is equal to KH, where K is the constant of variation. Let's try this. Write an equation for the following statements. Number 1. The fare of a passenger varies directly as the distance of his destination. So we can translate that as F is equal to KD. Number 2. The cost of fish varies directly as its weight in kilograms. In a mathematical statement, that is C is equal to KW, where K is the constant of variation. Next, an employee's salary varies directly as the number of days he has worked. So this is S is equal to KD, again, where K is the constant of variation. Next, the area of a square varies directly as the square of its side. Take note, as the square of its side. Therefore, A is equal to KS squared. Number 5, the distance traveled by a car varies directly as its speed. D is equal to KS. Next, the length of a person's shadow at a given time varies directly as the height of the person. L is equal to KH. Next, the cost of electricity varies directly as the number of kilowatt-hour consumption. C is equal to KL. The volume of a cylinder varies directly as its height. V is equal to KH. Next, the weight of an object is directly proportional to its mass. W is equal to Km. Next, the area of a triangle is proportional to its height. In a mathematical equation, that is A is equal to KH. Remember the phrases varies directly, is directly proportional to, and is proportional to are used to show direct variation. Let's have some examples. If y varies directly as x and y is equal to 30 when x is equal to 3, find the constant of variation and the equation of variation. So it is written here, y varies directly as x. First, we will translate that into a mathematical statement. That will be written, y is equal to kx, where k is the constant of variation. It says here that y is equal to 30 when x is 3. So what we're going to do is we will substitute 30 to y and 3 to x. After that, we can now solve for k, or the constant of variation. Divide both sides by 3. Therefore, k is equal to 10. This is now the constant of variation. We are also, so aside from the constant of variation, we are also asked to find the equation of the variation. Since y varies directly as x and the constant of variation is equal to 10, therefore the equation of the variation is y is equal to 10x. This is now the equation of the variation. Let's have another example. Y varies directly as x. If y is 10 when x is equal to 4, letter A, what is the constant of variation? Letter B, what is x when y is equal to 20? First, we will translate this statement into a mathematical equation. Y varies directly as x, so that is y is equal to kx. It says here, y is 10 when x is 4. So let us substitute 10 for y and 4 for x. And then solve for the constant of variation, divide both sides by 4. Therefore, k is equal to 5 halves. Since the constant of variation is equal to 5 halves, the equation of the variation now is y is equal to 5 halves x. Now, using this equation, we can now solve for what is being asked in letter B. What is x when y is equal to 20? When y is equal to 20, what is x? So in order to solve for x, we divide both sides by 5 halves. Therefore, x is equal to, so how do we divide 20 by 5 halves? Remember that in dividing fractions, we divide or we multiply the dividend by the reciprocal of the divisor. So it becomes 20 times 2/5. Therefore, x is equal to 20 times 2, that is 40 over 5. And 40 over 5 is equal to 8. Therefore, x is 8 when y is 20. Let's have another one. Suppose x varies directly as y and x is 30 when y is 6. Find the value of y when x is equal to 500. So first, we will translate this statement into a mathematical equation. X varies directly as y. It says here that x is 30 when y is 6. So substitute 30 to x and 6 to y. And then solve for the constant of variation. Solve for k. Divide both sides by 6. Therefore, k is equal to 30 divided by 6 is 5. Since the constant of variation is equal to 5, the equation of the variation now becomes x is equal to 5y. We will simply substitute 5 to k. And then, using the equation of the variation, we can now solve for what is being asked in the problem. Find the value of y when x is 500. Again, find the value of y when x is 500. So we substitute 500 to x and then we solve for y. To solve for y, we simply divide both sides by 5. We now have y is equal to 500 divided by 5, that is equal to 100. Therefore, y is 100 when x is 500. The table below shows that the distance varies directly as the time. Find the constant of variation and the equation which describes the relation. You can observe that the ratio of the distance to the time is constant, meaning that when you divide the distance by the time at each pair of values, the quotient remains the same. 8 divided by 1 is 8. 16 divided by 2 is equal to 8. 24 divided by 3 is equal to 8. 32 divided by 4 is also 8. 40 divided by 5 is equal to 8. Therefore, we can say that the constant of variation is 8. Since the distance varies directly as the time, then d is equal to kt, where k is the constant of variation. From the table of values, you may choose one pair of values. You can choose 1 and 8, 2 and 16, 3 and 24, 4 and 32, or 5 and 40. Let's say we choose 2 and 16. So substitute these values to d and t in the equation. So we substitute substitute 16 for the distance, and then 2 for the time. And then so for the constant of variation, divide both sides by 2. Therefore, k is equal to 8. The constant of variation is 8, so we can now write the equation of the variation. So what is the equation of the variation? The equation of variation now is d is equal to 8t. This time, let's have a word problem. A motorbike travels 280 kilometers in 40 liters of gasoline. How many liters of gasoline will it consume on a distance of 63 kilometers? Since to travel more kilometers means more gasoline is needed, so this problem we can say involves direct variation. So first, let us assign a variable that will represent the distance traveled by the motorbike. So let's say the distance traveled by the motorbike will be represented by D. And then the liters of gasoline, let's say G. From this problem, we can say that the liters of gasoline varies directly as the distance traveled by the motorbike. So that is G is equal to KD, where K is the constant of variation. Since 40 liters of gasoline is used for a distance of 280, we can now solve for the constant of variation. Divide both sides by 280. Therefore, K is equal to 40 over 280, or in simplest form, that is 1 over 7. We can now write the equation of the variation. We have G is equal to 1 over 7 D. Now the question is, how many liters of gasoline will it consume on a distance of 63 kilometers? In short, what is G when D is 63 kilometers? So we have 1 over 7 times 63, that is 63 over 7, and that is 9. Therefore, 9 liters of gasoline will be used for 63 kilometer travel. There is another way of solving this problem. Another way of solving this problem is by simply establishing what we call a proportion. From the given problem, 280 kilometers, we have 40 liters of gasoline. So 280 is to 40 is equal to 63 kilometers is to n. We write each ratio in fraction form. So we have 280 is to 40 is equal to 63 is to n. Let us represent the unknown using the variable n. Before we cross multiply, we can first simplify 280 over 40. This is 7 over 1 in simplest form. After that, we can now cross multiply. 7 times n is 7n. 63 times 1 is 63. And then now solve for n. Divide both sides by 7. N is equal to 9. So as you can see, we were able to come up with the same answer. Let's have another problem. A worker's paycheck varies directly as the number of hours worked. For working 20 hours, the payment is 1,000 pesos. Find the payment for 45 hours of work. So we already have a variable that will represent the worker's paycheck. So we will use P for that, and then H for the number of hours worked. So in the first sentence, it says a worker's paycheck varies directly as the number of hours worked. So let us first translate that into a mathematical statement. That is P is equal to KH. For working 20 hours, the payment is 1,000. So it means if H is 20, P is 1,000. So we have 1,000 is equal to K20. Solve for K. Divide both sides by 20. Therefore, K is equal to 1,000 divided by 20. That is equal to 50. 50 now is the constant of variation. If 50 is the constant of variation, we can now write the equation of the variation. Therefore, P is equal to 50H. And then we can now solve for what is being asked in the problem. Find the payment for 45 hours of work. So it means that what is P when H is 45? So we simply substitute 45 to H. So P is equal to 50 times 45, that is equal to 2,250. So therefore, the payment for 45 hours of work is 2,250 pesos. Let's try answering the problem using another method by establishing a proportion. So we have 20 is to 1,000 is equal to 45 is to N. 20 hours is to 1,000 pesos is equal to 45 hours is to unknown. So let us represent the unknown using the variable N. We'll write the ratios in a fraction form. 20 over 1,000 is equal to 45 is to N. Let us first simplify 20 over 1,000 in lowest form. That is 1 over 50. And then we can now cross multiply. We simplify it to lowest term in order to multiply small numbers. 1 times n, that is n. And 45 times 50, that is equal to 250. So the payment for 45 hours of work is 2,250 pesos. So as you can see, we got the same answer. So whatever method you use, you will come up with the same answer. So that is how we illustrate situations that involve direct variation. That is how we translate variation statements into mathematical equations. And that is how we solve problems involving direct variation. Thank you very much.